So we want to identify a point where this function is not continuous, it's discontinuous. So where would that point be? Let's look at the exponent. So if I apply the limit, now when would the exponent blow up? There we have e raised 2 over x. So if x is 0, then y is equal to 1 over 1 plus e raised 2 over 0, and that would be 1 over 1 plus e raised infinity, a really large number. The exponential of a large number is huge, and 1 over infinity would simply be 0. However, we can't jump to that conclusion. Why is that? Now, this is a tricky problem because when you come from the left-hand side, you are plugging in negative numbers. So let's say we plug in x, negative 0.1, negative 0.05, negative 0.001, negative 0.0001, negative side. And then we are going to plug in positive values from the positive side, 0.1, 0.05, 0.01, and 0.0001, right? I believe I have the function already. I'm going to set table set here, and I'm going to change that to ask, and go to the table. Negative 0.1, I have y to be 1. Negative 0.05, I get 1. Negative 0.001, I get 1. Negative 0.0001, I get 1. That clearly tells me limit x approaches 0 from the left-hand side of the function y is equal to 1. Now from the right-hand side, if I plug in 0.1, I get a really small number, 2.1 times 10 raised negative 9. 0.05, I get 4 times 10 raised negative 18, really small number. 0.01, I get 1 times 10 raised negative 87, and we know where this is going, and 0.0001, I end up getting an error, which pretty much is 0. So it's approaching 0. We are getting an error because the calculator cannot handle it. So the limit x approaches 0 plus of y would be equal to 0. So the limit at 0 doesn't exist. If the limit doesn't exist, then it sort of tells us that there has to be a discontinuity. So the discontinuity here is at 0. So the point is 0. Let's graph this. Let me adjust the window here. Negative 1 to negative, negative 2 to positive 2. And 0 to 2. And graph. So you can see it hits 1 up there from the left-hand side, and it goes to 0 from the right-hand side. So what type of discontinuity does this function have? This function doesn't have an infinite discontinuity, rather it has a jump discontinuity. A jump discontinuity is not removable. An infinite discontinuity is not removable. So we want to show in this problem that a root exists on the specified interval. Root in the sense the function's going to become 0. The function is x raised 4 plus x minus 3. And it is going to become 0. And the argument here is that it's going to become 0 on the interval 1, 2. Now, how do we go about doing this? We can actually use the intermediate value theorem. So f of x is x raised 4 plus x minus 3. So f of 1 would be 1 raised 4 plus 1 minus 3, which is 2 minus 3. You get negative 1. F of 2 is 2 raised 4 plus 2 minus 3, 18 minus 3, which is 15. So I'm going to draw a rough sketch. I mean, this is not an accurate one. I'm just trying to make a point here. So at 1, the function is somewhere here at negative 1. And at 2, it's at 15, hypothetically. So clearly, there has to be a number between 1 and 2 where the function becomes 0. So since f of 1 is not equal to f of 2, the endpoint values, they're not equal, and f of c is 0 for some value c. So there's some arbitrary c, and that is going to be equal, when you plug that in the function, it is going to give 0. And since 0 lies between here, f of 1 is less than f of c, which is less than f of 2. So f of 1 is negative 1, f of 2 is 15, and 0 is between negative 1 and 15. Then per intermediate value theorem, c has to be between 1 and 2. So f of c would become 0 for a value between 1 and 2. So root is simply the point where a function becomes 0. In other words, it's called a zero crossing. It crosses the x-axis.